What is up, YouTube? Today we are coming back for Robots Part 2. If you remember last time, we had three big issues. One, the arm was too heavy for the base. When we put the arm that I had made with the joint on top of the base, it started to fall over and strip plastic from the piece that was rotating the bottom. A solution for that is that we keep the same type of base thing with the square around it. Put a cap on top of the motor so the motor's covered, right? Then you put on the piece. Then there's another cap that goes over all of that to hold it down, so that kind of base is sandwiched in between a couple layers. So when it tilts left, right, it can put all the stress on those layers instead of the piece. Now, number two, the cap for the mini motors. So when we put in the mini motors, they fit great. But the issue was that I made this little cap that you kind of like put on, but with the arms in the way, you couldn't put the cap on, and it's kind of hard to put the arms on with the cap already. So I'm gonna do what I've never tried before, and I think I'll make a clip. So we'll have the base here and like a clip. So it's just a face with two things on the side, and then there's two entrance points on the box where the mini servos are, and you just boom, click it in, and then press down and slide it out. You know, classic clip, but I've never done it before, so it's going to be a bit of a challenge. Hopefully that will make the whole putting on process easier, and it'll be enough to keep those arms on there. If not, we can pivot. Now, number three, wires. So the wire situation is kind of crazy for me. I don't know how I'm going to do this, but I'm probably going to have some like indents in the robot where the wires can run down, and I'll probably have to extend some of the wires using like female to male wires to have extensions. But I want to make it look nice and real good. I don't know if I'm going to have a third part, probably, because I feel like, yeah, I want to make it as good as I can right now, but at some point I want to have it so like there's a joystick and it's like in like a plastic piece, nice and set up, and like with like green lights and like it's on, no too heavy, blah blah blah. You know, I kind of want to do all that and make it real fancy, but I don't want to spend too much time. So I think today, or in this video at least, I'll make a very sophisticated and nice put together, but I'm not going to go final product. I'm going to go just the arm is working as well as it can product, and then I want to start the next project before I do like a super finishing touch on this one, you know, because this is something more basic, and there's other ideas I have in here that I want to, you know, put out there. So I think that sounds good. Let's head back. So this is what I made so far. As you can see, this is the cap I was talking about that goes over the motor. Now I combine that cap with the base that you saw in the previous video surrounding the bottom of the motor, and together these two prints will hold the motor in place. I also want to explain what this piece here is on screen. This will represent the star attachment for my servo, so I can accurately gauge how high and how wide I need my print to be. So what I want to do right now is create two sketches on both sides of my upper piece, right outside of where the lower piece wall is, so I can have the upper piece slide right over the lower piece and maybe make a slot so it can sit in there perfectly, and that it would be nice and fast. And so my sketch is nice and lined up. I'm going to put points on the corner of this square because for some reason I cannot get the square to import its geometry when I do the sketch. So this is my little fix by putting points on the very corners so I can have a nice and lined up sketch. Now that I have this side done, let's extrude it about 0.05 inches. This is not too flimsy, but it's also not too thick. I really like this width. For a first try, I think this looks pretty good. So now I'm just going to do the other side real quick and I'll get to you. So I just made one real annoying mistake while doing this other side. I accidentally used the join feature instead of the new body feature. So I merged together two of my bodies, the lower and the upper piece. So I'm going to just redo it real quick without the join feature and the new body feature. So they're two separate pieces. Boom, that looks good to me. Now what I need to do is make holes here, here, and here to fasten the two pieces together. I decided to do this instead of the slot idea I mentioned earlier because I think that this would make it a lot easier, because if all three pieces have the same screw hole, then they would have to line up no matter what, and it would keep them clamped together. So now I'm going to use a tool I've seen, but I've actually never used before, the symmetry tool. I want to have both holes exactly the same on both sides, and I don't want to have to redo it twice. So what I'm going to do is I'm going to make a line on the bottom of the square, put a point, do the midpoint constraint, so the point is directly in the middle. Then make the same thing on the other side, put a line in the middle, and then I use that line in the middle as my symmetry reference. So with the symmetry tool, I should be able to select the 2 points where I want the holes, and then I just click the line and it should, boom, flip over. Let's see how it goes. So that symmetry tool worked perfectly, and now I extruded those holes that I made with the tool, and now there's a perfect place for the screws. So let me share my vision with you guys. Now you can see the new redesigned lower arm part. It fits perfectly over these parts that I've been making right now. What I want to do is make a third part that goes over the cap you just watched me make, which will sandwich the two together, making our motor sandwich, and hopefully will take all the stress we need off of that servo motor. Now with that new solution comes the new issue. So just like the cap for the mini motors, I don't know how to get this thing on, because the only way I could really do it to make a sandwich would be to slip it over the top of the arm itself, but I can't really do that because I need a fixed circumference. So what I was thinking is that I make a 2-part cap to go over all of this. What I mean by that is I make the design, then I split it in half and use the same clip method I'm going to use for the cap on the mini servos. So that way I can put one side on, then the other side on, they connect in the middle, and then I screw them both in. Hopefully that could do the job. Now before we try and tackle that Titan, let's worry about making the cap that's going to go over both of these caps so we can make a test run to make sure this thing at least moves smoothly. So what I'm going to do to make this overarching cap is make a sketch on what we have of the new lower base, right? And we'll go right outside of the circumference of the lower base, and then we'll make another circle about 0.05 out, that distance I really like. Then we'll extrude it down to the surface of our other cap that goes in the middle, and we'll go from there.
So as I was explaining that, I was also doing it on screen. And to you and me, that looks like a cap. So I think we're good to move on to the next part.
So this is Bamboo Lab, where I load up my 3D prints and then upload it to my 3D printer. As you can see, I have my 3 pieces on here, plus a little cross section of what I want the lower arm to look like eventually. But as you can see, it does not have the top part because I have not made that whole clipping system yet. Well, it says this print's going to take about an hour, so I guess I'll see you guys then.
Alright guys, the print came out and it looks like I forgot to enable supports on 2 of these pieces here. So I'm going to redo this print and I'll get back to you when it's done. Alright guys, here's the new print. Let's get it on the table and get to testing. Okay, let's take these parts off the plate and see how they fit together. But before we can do that, we have to take off all the supports. Okay, just like we wanted, these 2 parts slide right over each other. Let's test these other 2. The top cap is also a good fit, but as I'm putting this on, I realized that I forgot the hole that goes around the servo motor, so I think I'm going to have to reprint that. But we still have these pieces in front of us, so let's see how they fit and if there's any other problems. Okay, the lower arm seems to slide around pretty well and is not a loose fit. So I think we're good on everything besides missing that hole on the top cap. Now let's take the motor out of the old base and put it into the new base to see if our hole is the right dimension. Okay, this seems like a perfectly snug fit around the motor. So now let's test the cap and if that star piece fits well on the new lower base design. So we still have some things to fix. I need to make that hole in that upper cap piece. I'm going to extrude down in the lower cap piece, and then I'm gonna spread out the holes or make a little teardrop design to make it easier to screw in. So I'm just come back to you when I did all that. Alright, so here's my reprinted servo sandwich design for the base. I wanted to reprint it and see if my new modifications worked before I went with the full product, so I didn't have to reprint a whole lot. So I'm going to test it out with a potentiometer and this little breadboard setup. Look at that thing move. I don't hear any friction against the parts, and it moves perfectly well. I don't see any odd power usage or anything that looks like it's going wrong. So I think I can go ahead with this final design. Alright, so before I get to my final robot, let's show you the clips I was talking about. So like I said, On the front with the mini motors, I wanted to have a kind of faceplate clip over them. So here I made a little loop. So what I'm going to do is I'm going to make an arm that has some tension outwards, but when you push it towards that loop, there's going to be a triangle that slopes it in, and then that tension pushes it back out. But on the other side of the triangle that went in is going to be a flat edge, so you have to push it to get it back out. Alright, here's my first attempt. I feel like it came out pretty well. As you can see, we have that triangle with the flat edge, and boom. I think it's a little bit thin, but I want to print it first to see how it is. For never making a clip before, I feel like this is going to turn out pretty well. Let's hope for the best. Alright, so here you can see I extruded and duplicated the shape I made on the one side onto the other side. I feel like that looks pretty well. All I have to do is make a faceplate that connects the two. Now let me tell you my fix for the wires. So, as you can see, I printed my lower arm, but what I changed is I put a hole in the middle of the shaft. So, you see these wires up top? They run all the way down to a hole in the bottom of the lower arm. That exits right next to where the base's wires are. So, my wires stay nice and hidden until they unfortunately get to the breadboard and Arduino where it's all messy. I also repeated the same thing for that red tube you see in the background, which has wires that connect through the black piece. Bit of a sneak peek here, but I wanted to show you guys what the wire run through looks like all together. So we know that the highest wires come from these two mini servos at the top. Then they run down here, down the red shaft. Then they connect through these extension female to male wires that run down the black shaft along with the servo in the joint. And then this comes out of the bottom of the black shaft, meeting up with the base servo motor wires. I feel like I did a pretty good job. So now I took my newly designed parts and I put the whole thing together. I think it looks pretty neat. Now I plugged it in for the first time and let's see how it runs. Well, it looks like it's pretty good. It's moving left and right, up and down, all well. I don't like how jumpy it is though. I think I'm gonna recode it to where it moves in a slow motion based on which direction the joystick's in, instead of it just moving to the value of where my joystick is at. But before I make those easy tweaks, I want to work on the opening and closing of the claw. So here's my code. I made an if statement that is checking when the button is pressed. It does this by saving a past value and comparing it to the current value, seeing if the button switched from a high voltage to a low voltage, meaning that it was pressed. So when this happens, the claw either opens or closes based on whether the claw state is 0 or 1. So when you press the button, the claw will close, and if you press it again, it will open. If you press it again, it will close. I like it this way so you can easily control the claw without having to hold down the stick. With the new claw code and all the tweaks in the code that I talked about before, here we have it. The final claw bot. Now let's go through. This is our double servo claw with the detachable clip cap that we designed in CAD earlier. So this thing comes right off, and underneath you can see the two beautiful blue mini servos that attach to these two black talons. This claw opens by a simple press down on the joystick like this. Open, close, beautiful. As you can see in this clip, the movement of the robot with the upper and lower is a bit glitchy. I am not even able to rotate the base, and you can see that this is a very jumpy top movement. I'm going to come back when I fixed it. Now that I've fixed the coding, I've taken my robot to this table to try and pick up this cup. As you can see in this clip, the arm moves perfectly fine. So let's try and pick up this cup now. Bit of a claw strength issue there, so we'll try and fix that. So now that the arm itself is working, I want to do some other things to it to make it look nicer and function better. So one of those things would be taking all like the wires and the Arduino and putting it in like a little black box or box so like no one can see in it and it looks less messy and all the wires can go into it. And then I want to have the joystick pop out of that box, and I want to create a outlet or like a hole so you can plug in and power with a mobile like a battery or in-wall charger, so we can have it a fully like mobile device. So let's do that. So this is the design I came up with. I basically just took the old base that we had and I extended it enough to where it could fit the Arduino and some wires plus like a box with some walls. And I did this by measuring the size of the Arduino with a caliper. So now what I'm going to do is I'm going to make a removable wall that we can screw into this base so that we can put the Arduino and the wires inside this box. This is what I ended up making, and it's honestly pretty simple. I made it open capped so I can make a lid for this, and that way we can just cut a hole into it and make the joystick a separately wired module that we can put in after, and it's removable. This will allow us to openly fit items and mess with the wires after we have put the stuff in. This is the lid I made for the box, and the hole that you see in the top is big enough for the square module that the joystick goes onto. So this way we can slide it in, put the joystick on top and screw it in, and it will just look like a joystick on a box, and I think it will turn out really nice. Now let's see what it looks like and put it all together. Right now what I'm going to do is I'm going to hook up the power supply so I can turn on the motor, so I can put the motor in its halfway point so that the arm can be properly attached at a midway point. So I can connect the power rails on this breadboard. What I'm going to do is I'm going to take this 1 million ohm resistor and cut off its ends because I don't think I'll be using 1 million ohms anytime soon. And then I'm going to use the ends and bend them to connect the power rails. This way I can use as least space as possible and connect all the power. To test if the power is being properly transferred, I'm going to take this blue LED and plug it in to see if it lights up. Now that I have power, I'm going to put in a motor, and then I'm going to turn on the motor and try and attach the arm after I have the motor at its halfway point. Now that we have our motor and star piece in, let's run that code so we can get that star piece to its halfway point. I'm going to use my other Arduino to do this because I can live code it through a USB connected straight to my PC. This is just easier for me to do, so that's why I'm using this other Arduino. Now that it's ready for attachment, let's do exactly that. The side fastener design I made didn't work to putting the two sides together, so I'm gonna just use this electrical tape as a fix, and it matches with my color scheme, so it's not a bad idea. I could eventually change it, but I don't think this is really a big deal. Now that it's all put together, let's get this thing wired up and do some tests. The base servo is now plugged in, so I'm gonna just test it out to see if it can move. Looks like it has a perfect 180 rotation. I think it's good to go. I just noticed that when I put this cap on, there's no hole for the wires to sneak into. So you see the pencil mark on the cap with the joystick? I'm gonna cut that out with the Dremel. I cut the hole, but there's a lot of rough plastic, so I'm gonna clean it with this razor blade real quick. That looks like a great fit. I love it. Now that I'm done with that side quest, I think we should move on to making the joint motor move, which I was doing before. So let's get to that. Now that it's all plugged in, it should go straight to its home. Whoa, which it did right there. And it seems to move around just fine. Now that both of the big motors are done, let's get to the small little claw motors, and that's going to be more of a difficult task. Well, I guess I lied. That was a lot easier than the other two motors. Wait, I'm not a liar. See, now the left side of the claw isn't going. I think it might be a wiring issue, so I'm gonna check this out. I'll get back. I think the issue might be this Arduino board, so I'm gonna just plug my claw servo into this other Arduino board just to see if that might be the issue. Well, it's still struggling to move, so I don't think that was the issue, so I'm gonna take a second to figure this out. Oh my goodness, I think it was one of the dumbest things ever. It was this little piece on top that was just too tight. I think the claw should open and close just fine now. Oh Lord, it does. Wow. Okay, next thing. The next thing to do is putting on the arm cap. Let's see how that goes. Because I have a feeling that the motherboard for the joystick is going to collide with some of the cable ends because these are not soldered in cables. Wow, that took a while. So I think let's give the thing a test run, huh? Let's see. Okay, it started up. Wait, it seems a bit unresponsive here. I'm trying to move it and it's stuck. It's not moving. Yeah. Okay, what the heck happened? So I just put this thing on. I think I gotta take it back off now. Let's try and figure out the issue here. So now it's not moving again. Let me feel around the board. I don't see any loose cables and it was just moving a little bit. So it couldn't be any connections because then it just wouldn't move at all. I'm feeling the board here and actually, wow, there's a really hot piece on here. So I think that this board may not be able to handle all these motors at the same time along with the hot and cold wires because maybe it just doesn't have the power for that or the battery is too much. So I think I'm gonna have to use my other Arduino. It's on brand, more heavy duty version. So I think I'm gonna have to switch them. I was hoping to keep the heavy brand Arduino for my next project, so that's why I was using this cheap one. But I guess I can use my other mini Arduinos on the next one. So let's switch these things. Well, I was able to switch the boards out just fine, but here's the new issue. The heavy duty board is actually a bit bigger because it has a plastic base, so you can actually fasten it in properly. And because of this base, I'm not able to fit in my breadboard, which is a perfect fit with a smaller board. So I'm gonna have to be creative and figure this out. Well, it actually looks like it fits just fine if I flip it upside down and just put it in here. So I think I'm gonna try it like this and see how it goes. And voila, I got the new board in there and I was testing it out during that little time lapse there and it didn't seem to overheat at all. So I think this does the job. And that means we now have our final version for now. Here's our final project. A fully portable robotic arm. So the reason why I have this hole here, if you guys are wondering, is so I can switch power sources. Because I also have the on-desk plug, which I can use. So here's our thing. I mean, it does everything you guys already saw. Moves left, moves right, up, down, open, closes. But all I really did was make this look nicer, nice and portable. And look, all you see is a joystick. It's pretty cool. It's like a little toy. And so yeah, this has been my first robot. All right, so that was it. That was the Clawbot finished. I mean, I like it. I mean, it looks pretty sleek. You can't see any wires besides the power source and connecting to the motors. Like, it's not that bad. I like it. It moves at the speed I want it to. It closes and opens. Pretty functional. I think I like it. So I really appreciate you guys for sticking around to see this robot finish. If you do like the video, give a like. If you want to subscribe. I'd appreciate it. And comment down below what I should make next. Thank you guys for watching. This has been my first robot. Peace.